foundation within a foundation that allows benefiting from the intellectual property management services, the infrastructure, the staff who provide IT support, marketing, all these kinds of services, basically turnkey, ready to go. I guess you can spin an organization up very quickly that way. Now, ultimately, I talked about industry collaboration. The reason why this matters, if you actually look at the numbers, 2/3 of R&D spending is actually coming out of private industry. So when you look at academia or government, it's actually very tiny in comparison. I've never seen in my 23, 24 years of doing R&D, I've never seen a project that was overfunded. That said, oh, we have more funding than we could ever possibly use. Scarcity is always a problem. And so collaborating with industry is very important because that's where 2/3 of the R&D investment is. So if you're basically doing work and you're not considering and not engaging with industry, you're making a big mistake. It's a very, you're basically reinventing something that's already been invented and perhaps better. Or maybe you're not fully considering something for wide adoption across the industry. So these are some of the projects that we host. It's kind of interesting to see, particularly I'm going to call it the ones where you see IBM and Oracle and SAP. But look at the WTP project, this is the Web Tools platform. These companies are absolute fierce competitors in the industry. And so the reason why the project came to Eclipse and the reason why it's thrived at Eclipse is our governance model, our infrastructure, our services help keep them in balance. So they actually help them to collaborate, working towards common goals, which is really quite interesting. Some of these other projects, the Linux Tools project, for instance, you see some universities along with some very big technology companies. So this is what we like to see, is basically collaboration across the industry, government, academia, and basically people accomplishing, pushing the state of the art forward much more than we could on our own. So that's it for me. Question? Sure.
Quick question. In terms of collaborating with industry, I definitely understand the value of it and the financial portion of it. How do you collaborate with industry without compromising or having conflicting values and also in your end products? Or how do you direct that?
Well, this is again where an open source project with a clear governance model that says this is what we believe in. These are the rules that you're going to participate in this organization. So openness, transparency, these types of values and principles. These are the rules that if you're going to contribute code. In this particular part of the session, we're talking about software. This is what this means. So these are the terms in which you're contributing that code under this license. You retain your copyright, but you're also giving a license to people who use it. So actually having that clearly written down so that people know what they're getting into is very, very important.
And like a legal contract.
Because otherwise it's very murky and uncertain, and uncertainty means risk, and risk basically sends everybody running to the hills. So.
Okay, thanks.
Thanks, Andrew.
Hello everyone, my name is Miriam. Thank you Tom for organizing this. Thank you Alfredo for the invitation. So I work at CERN, which is in other words the European Laboratory for Particle Physics. They run the Large Hadron Collider doing research in particle physics. And recently they have started looking into open source hardware. So I'm going to tell you a little bit more about open source hardware in general, but more specifically the CERN open hardware license that we have developed and that we are using for certain of our projects. Why open source hardware and what is it? Basically, with the rise of personal computer, you have seen the development of open source software. With other technological and cultural developments like 3D printing or hackspaces, the Instructable, and this new culture of sharing, we see the development of open source hardware. So what is it exactly? It's basically about designs which are made publicly available so that anyone can study, modify, distribute, make, and sell the design or the hardware based on the design. And all of that, going back again to the same principle, in the spirit of sharing knowledge and encouraging commerce through the open exchange of designs. So the very basic tenet here again, like for open source software, is collaboration. I know this is very small, this is not for reading, but just for your reference, there is an open source hardware definition that exists, version 1.0. With a quick Google search, you can find it. The principles are very similar to the principles of the developed by the Open Source Initiative. There is also another organization which is called OHENDA, which has developed a certain number of principles for open source hardware, and which is trying to develop a model for third-party certification. Okay, yes, I certify this is an open source hardware model product. At CERN, how did we actually come about open source hardware? It basically all started with one of my colleagues who works in the beams and control department, Hade Serrano, came to see me, and he was very adamant. He was like, well, you know, look at those guys in the IT departments. Look at how they are developing software. They're having fun. This is really good. I want to do the same, but with my designs, for my electronic cards. So he was very, very enthusiastic, and he wanted to create a framework for collaboration among the research institutes, but not only research institutes. And being at CERN, you know, you have to kind of be a little bit careful about what you do, so he figured out that you basically need some kind of legal framework behind this. And the basic principles that he wanted to apply here was to make the available designs and documentation openly, so that it could be modified and redistributed by all, and so that companies could manufacture the products without CERN being further involved in there. Because basically the model that we use at CERN is a lot of the hardware that is being used is developed from scratch by the engineers at CERN, and then we need to find a company to manufacture it. And when you start looking at documentation or designs, blueprints, etc., you enter into various kinds of discussions, and not only for the designs themselves, but everything that is around the calls for tenders, etc. Ultimately, open hardware ties in very nicely with CERN mission, because CERN mission is first the research that we are conducting, but also to give back to society in one way or another. And there are different ways of doing this. Open hardware is one of those ways, also because it encourages smaller businesses to enter into manufacture of certain products based on open hardware. Here, I realize you have already heard this from Thomas and Andrew, but open is really different from free. It's about not subject to obligations. There are some obligations. Open also is very different from non-commercial. So we are not basically opposing open hardware or open software to commercial activity. What it means is that it's accessible, not kept secret. There are a number of advantages for open source software. For designers, basically, you avoid the duplication of efforts. There are chances that somewhere in the world somebody else is working on something similar to what you're doing, or that could actually benefit your project. So you're tapping into a huge pool of potential skills and expertise. You get peer review and help from your fellow designers, and you can tackle more ambitious projects. For the companies, this also means that you can probably discuss more openly with the people who are at the origin of those designs. And you can get help from them to solve some of your technical problems. Low entry barriers. when you are a small company, you don't have certain R&D capabilities, well, you can get access to different types of designs and just embark on the manufacture and on collaboration with the different communities that are around this design. And you are also able to build hybrid solutions. Part your own proprietary design and part the open hardware design. And for clients, no vendor lock-in. You manage to also have reasonable prices when you're designing something, better competition basically. And the competition, which is not only lower prices, but based on quality and added value that you are going to be able to get from the company. So why a specific license? So when Javier came to see me, we tried to look at a bit what was the best way of tackling the proposal that he was making. We looked at open source software licenses, but open source software is very specific, and there was a whole part of the project that was not covered there. I mean, the fact that ultimately you are going to be manufacturing products is not at all covered there. Open content license. So, for instance, a GNU Free Documentation license or Creative Commons. It's very specific also to documentation and completely ignores the hardware, the tangible parts that you have afterwards. And in fact, we also came to realize, well, there are other open source hardware licenses out there. For instance, the Taper, they have a commercial and a non-commercial license. The EPUB, which was developed by engineering school in Switzerland. But it didn't match exactly, or it didn't match very well with what we were trying to do. Taper was very US-centric in the way it approached a certain number of issues. For instance, a debate between is it a license, is it a contract, which is not necessarily entirely applicable in Europe. So we embarked on drafting our own license, the CERN OHL, and we had a couple of concerns. One of the concerns was we wanted to track the impact of CERN research on society, because this is one of the main missions. We wanted to be able to somehow see what was out there, what was used, and be able to talk about it as well. Also, because CERN is an intergovernmental organization with 21 member states, there was a special status and special constraint that we wanted to take into account there, which I'm not going to go into details because that's probably not relevant now. But the current form of the CERN OHL basically is usable by anyone. Anyone can take the CERN OHL and say, I am licensing my design under the CERN Open Hardware license. The principles of the CERN OHL are similar to the LGPL, so it's a, how did you call it, soft copyleft license, which basically means you, the original licensor, can benefit the same way as the licensees to whom he made available the original design. And this is also a way of making tracking possible. So the CERN OHL has a set of definitions, being a nice legal document that we know. In terms of applicability, what we are covering is the documentation and the product, not accompanying software. So software that can be run on the hardware would have to be covered by a different kind of license. Warranties and liabilities is one of also the very important points in this kind of document. And we have the general clauses like the boilerplates, applicable law, the duration, etc. So in terms of scope, we're looking at two things: the documentation on one hand, and manufacture and the products on the other. What you can do once you have documentation covering the design of a hardware of a product, you can use it. You can copy the documentation. You can distribute the documentation. You can also modify the documentation subject to certain conditions. So the first condition is to keep the notices and the disclaimer of warranties. You also need to make clear that documentation was modified, and you need to, if you decide to distribute your modified documentation, then distribute it under the same terms as the original, which is the CERN original. And if the licensor has expressed its interest of being informed, let the original licensor know that you have created a new version of the design. A license to the patents, yes.
How do you track the version of the modified documentation?
Well, that's one like for a software project, you need version tracking kind of system to be able to know what you do. For instance, if you have the basic copyright notice, then you need to, if you're relicensing it, you add your own copyright notice covering the different work, the difference, and also specify what kind of modification you have to do. It has to be some kind of tracking system like you want.
Say CERN has a design, okay, and then I use that design, modify the design, and along with the design, I made a modification to the documentation. CERN has its own way of tracking the change from their end. So if I made a change to documentation, I probably keep track of the change on my system. So how do you track the change that I made?
So you have